If you like this video, make sure to subscribe to our channel and hit the notification bell icon to get the latest updates.
What I was thinking is, since basically from a SLT perspective, you mentioned that's from our last previous conversation. This is one of the thing which you would like to focus on with the practical and everything. And before that, you mentioned about the sidecar scenario as well. And a couple of other things what we discussed about. Making a replica of your practical scenario, whether it's a ECC or any other system from where you want to replicate the data to HANA sidecar. So definitely, so that's I would like to start with that. But before I go there, I would like to understand, how's your SAP HANA Foundation and the deployment strategies are. So do you want me to just give you a brief about these things before we deep dive, or because this is the prerequisite, to deep dive into SLT topic minimum?
I think actually, we can, because I'm kind of like people are waiting on me to do something. So let's start with the sidecar scenario. I know a little bit of like those things, but if we can cover them as we go, or come back once we finish this scenario. So I'm very much interested in first, like I said, doing this, replicating the data from other system, and then doing a simple query first, to start with, and then we can build on that. If that's okay.
Yeah, I think what I'm gonna do is I will just take 15 minutes, just to talk about the HANA architecture first, and then basically going to sidecar and the deployment strategy. It will not take more than 15 minutes. When further on, if we need to deep dive into any of these, we can do that, and then after that, straightforward. After that, I will deep dive into the SLT, with some practical things as well.
Okay.
So, from a architecture perspective, so I will be using a lot of SAP help, as well as some mixed documents from that I created, and then we have some PPTs as well that I will be using. So let me know if you want to see the different perspective of something. I will cover that as well then.
So you're going to keep all these, whatever you're showing me, as part of the materials posted there, for the class, or?
Correct. Yeah.
Okay.
So anything we are using, by end of the class, I will take 15 minutes and send that across to you. With every session we complete, I will send that across to you. Yeah.
Okay.
So starting with the HANA, very 10,000 feet view of your HANA architecture. So it's as you know, it's in-memory database, and it's been there since 2011 now. HANA 1.0, then 2.0, basically, and 2.0 with revision 35, 36. That's new, and there are patch levels as well. From that perspective, now the talking of more of pre-processing server, name servers. These are kind of a services, which is the index server and the name server. Both are important services within the HANA ecosystem, right? Within the architecture of HANA. The name server itself holds a lot of your data calculations, data part of it. The indexing index server holds basically most of your in memory computing things as well. So if these two services, any of these services goes down, that means your database is impacted. There are some orchestration services as well, like DI services. Then there are basically more of replication services as well that I will get in deep when we start with the SLT. But those services are more of a orchestration services, from that perspective. Then sitting on top of it, it has more of a data in the transaction logs, which we call as a persistence layer, which is sitting in your persistence layer, like a SSD, or your storage, it could be SSD. Most oftenly we use SSDs, but it could be your SAN storage as well, depending upon whether it's a tailored data implementation, or it's out of the box, like a what we call it as HP, or bare metal field, um, or basically Dell, so those kind of implementation, those are categorized as more of your tailored data implementations, and in that we use SAN rather than SSDs basically. So so question back basically, so are you aware of the hardware piece, what we use basically, or do you want me to deep dive into those areas as well?
Yeah, go ahead. Go ahead.
So from a hardware perspective, so in specifically in cloud, now if we talk about hyperscalers like AWS is there, Google is there, then you have Azure. There are predefined machines, so those are certified by SAP to run SAP HANA on those VMs, or the predefined machines basically, within those hyperscalers. But when we do this implementation basically from a HANA perspective on in the data center, which is on premises, that's a tailored data center approach. We have our own storage, our own hardware network, everything can be mix and match, but definitely that needs to be certified by SAP. And there are components like storage, and network, those are certified by SAP, and those are certified for vendors like HP, Dell, and these. So these are the two approaches how we deploy, HANA basically on premises versus cloud. If we have to say, then on top of that, basically the data engines, that's sitting in, which is again your SQL. You can do your SQL scripting. It supports R. It supports the calculation engines as well. About the views as well. So all that basically that's sitting in the data engine in this layer basically right here. And this green part, what you see, this all is within your index server, which is your primary brain for HANA basically. And if you see, this is marked as index server over here, this green column. And MDX processor, SQL processor, so MDX queries are primarily used in BW scenarios, and it's very powerful when it comes to from a data mart perspective, anything related to your BW. But normally we don't use MDX in the transactional systems like ECC or S4. So then we sessions and transaction manager, that's plays an again important role basically in the session and the transaction manager for your maintaining the transaction volumes and handling those transactions, based off your transactional systems like S4 and ECC in this case. Now this is the till over here what we have discussed is the part of your database. Now on top of that, there is a web server that is sitting, which is this your orange box over here. And there is an application server which is called Access Engine, and now it is called Advanced Access Engine as well, basically. So that's also a part of your access framework. There is an application server, there is a HANA client libraries. How it works is in the UI library files, so, and those can be defined as same as your Fiori technology, which is your UI path and web servers, and that you can expose as your OData service outside of HANA, just like how we do that in Fiori based systems, for S4, the new architecture basically. Any questions? I will take a pause over here.
No.
Okay. Now, this is the very high level, and again, if we have to deep dive into it, then we will circle back on this one definitely. Now, the another thing about the deployment strategy, and let me bring it back over here. So
So what are the practical scenarios when we use Access Engine using native
So
HANA?
yeah, so in the the one of the example, and this is one of the example, but I can give you more scenarios as well. Like, if you want to expose your let's say, your CDS view, and you want to expose it as a O data service basically, and rather than going from an application layer, you can go directly from your HANA and expose the data in that particular table or the CDS view, through the O data. And the advantage of doing that is, basically, it's there are two different approaches. Sometimes we recommend, sometimes we don't recommend doing that. There is a advantage of that is if the data calculation is really huge, then basically you want to replicate the data for, let's say you have a pricing module, within your pricing data within your database. And the pricing data is basically quite a huge, in couple of terabytes, and you want to replicate to a third party system, or you want to present that as a O data service, as a Fiori tile to a third party system outside your landscape or within inside your landscape. Then you can expose that data directly out of Access Engine rather than going from your application layer. And the advantage of doing that is your processing time on the CPU side, memory side, on the ECC, then going through your Fiori side, that all that is reduced. And the performance output of that is, relatively huge, as we compare to going from an application layer. But again, so S4 HANA is more, equipped with the CDS, push down technology. Push down, when we say push down, that means, all the heavy lifting is happening basically within your database, and you are not doing your calculation and for the code basically within the application layer, that you are doing down on the database layer basically. So it is more beneficial when the data volume is not huge, always go through S4 HANA, or the Fiori scenario. But where it is not possible, then we can use Access Engine in that case as well. That's one of the example. But there could be more examples as well, as we discuss. I will keep pointing that, as we go forward.
Okay, so like practical use of it, like what percentage of implementations do they really use access
Um,
based
it
approach?
to- it it totally depends on scenario to scenario, but the percentage, if we want to compare, we can say easily 90 versus 10. In most of the implementations, we don't use Access Engine a lot. The advanced Access Engine is basically used in the very complex scenarios, rather than opening your database layer completely out, because you are running your um, transactional based system, which is your database on the primary HANA database, and then you're going to use on top of that the application scenarios as well. That will kill the performance of your entire HANA database, rather than enhancing or giving you something better than what you're going to get from your application layer. So it's still there are very few use cases, very few implementation scenarios as well. But definitely the ratio is, you can say 95% or 10 to 90%. It's very less basically from that perspective.
Okay.
Now, coming from, let me share this one. Just give me a moment. I'm opening a slide over here. So, from a sidecar architecture perspective, so just want to make sure, there are three different deployment strategies, and I will get to the sidecar before I get to the, this particular diagram. I was looking for a diagram, just to show you how the sidecar scenario works basically. And the first one, what we have is, on premises, which is called tailored data center approach. That's called TDI. And that's the, as I explained initially, so you bring your own hardware. You buy the storage from Dell EMC, Then you have network from the network card and everything from Cisco or Juniper, wherever. Then you have your memory and the CPU and everything from Intel perspective. You provide, you do everything as an integrated system. Put that in your own data center, install HANA on top of it, and call it good. Yeah, that's the old school way, how HANA 1.0 was implemented by most of the Fortune 500 companies, right? The second way of doing that is, obviously in cloud, with any hyperscaler, basically in AWS or in Google or in Azure. Now there is a predefined, there is a hardware library basically. So if you look for the certified and supported HANA, SAP HANA hardware directory, so this will give you pretty much anything that is certified as of today, by SAP. Now, in this one, there is a way. Are you familiar with this one or no?
Yeah, I mean, yes.
Okay.
I read theoretically,
So,
yeah.
okay. So then I will not do a deep dive into this, but I will use this as a, from a example perspective. Like for the Taylor data integration, we already talked about it. Then, if we talk about any of these vendors, basically, let's say, yeah, Amazon Web Services, so, and there is Google as well right here, and there are a couple of others. So if we talk about these ones, so these are the large instances, in instance, bare metals, basically, those are already certified by SAP, for AWS, and where you can run your HANA instances. That's a second way of deployment. Now, the third way of deployment is no different than these two methodologies, but the way how you're going to do is, there is no right or wrong architecture as well in Sidecar. But there is only one way to do a Sidecar, and Sidecar is not that much popular option, unless and until there is a specific need. And I will get into those needs, now, but definitely, it's not very much popular as we speak today. It used to be an very useful option when the HANA got introduced, and there was a lot of pain point when there was a lot of use case of Trex engine, in the BI queries inquiries, so at that time it was basically very useful, but nowadays hardly any company uses that, but there are scenarios. And I will tell you, I was working for one of the preparing an architecture for one of the company, in recently I have suggested Sidecar to them based on the scenario, and I will get into that as well, what was the scenario. But before we get there, so the Sidecar scenario is nothing. Basically, it's your just HANA system and no access engine on top of it. Basically, there is no application in a distributed environment. So it's a standalone HANA instance. With your particular set of memory that you can use to as a kind of a data lake. In the modern world, what we call it as a data lake scenario, where you can dump the data, and after the replication, and then you process that data basically with your reporting tools, with the ETL scenarios, and so on. Now, in this example, if you see, this diagram is the perfect example, where you have your SAP HANA system, as a Sidecar. Then you have your ECC, or S4 in this case, in the newer architecture, where you can use this as a replication, basically for the data replication, traditional database through SLT, that the data is getting in and out to your Sidecar. And the scenario what we were discussing in our previous call, there is a BI tool which is kind of a reporting tool sitting on top of it, from which you are doing a reporting, and that's a very typical scenario how you see basically Sidecar at any given point in time, when we see a Sidecar implemented. Now, one of the thing is, it could be SLT over here, it could be your any other replication tool, like your TDMS, Attunity, and there are a number of replication tools as well. But with SLT, specifically, we will get into a deep dive into this one. So let's assume, you have multiple source of your data, ECC as well, non-SAP systems, multiple non-SAP systems, multiple SAP systems, and you want to have your own data lake with all that data, so it is very much possible to bring the data from those source systems through a replication technology, which is SLT, and transform that data on the fly without doing any without doing anything basically with the data in the source system, right? And that put that into your sidecar scenario, so that's I believe that's the scenario what you where you are working right now. It should be similar to that. Correct me if I'm wrong.
Yeah, that's correct.
Okay. Yeah. So that's a very typical scenario, and if you allow me a minute over here, I would like to start with a practical where I would like to log into the system and start basically showing you some SLT crux, how that works. Give me a moment.
Sure.
If you want to take 5 minutes break, you can, because I know this will take 5 minutes, for me, just to log in into the RDP session and everything, and bring the system up.
Okay. Yeah, sure.
Start with a theory piece of it, and I will walk you through the screens, once the server is ready, so from, I think they're patching the license, at this point in time. Sorry about that.
Okay.
So, are you good to start, or you want to wait?
No, go ahead.
Okay. So, from a data transfer perspective, so from if you I will be using a lot of diagrams, let me know if you want to, go through, and feel free to interrupt me anytime, you feel like. Now, in the source system, basically, let's say there is a table XYZ, you want to replicate that over to SAP HANA Sidecar system, and in this scenario where you do your configuration in LTRC, basically, you maintain the connection, and everything. Basically, there is a transaction, LTRC, LTRC SAP. Let me see if there is a. So what we do is basically in this one there is a mass transaction ID, which is an auto generated number, by SAP system, that is maintained within the backend table, basically. And this is something we don't have to give. It's auto generated. You just give the basically a replication name. Let's say, you want to replicate your XYZ table, from source system through SLT, and you will go into LTRC transaction, and you will maintain the connection details over there, and after maintaining the connection details and everything, which will be, in this particular step, the configuration name, and you will maintain the alternative selected entry within the display name. And I will walk you through this once we have system ready. But just to give you a brief idea, how it works. Once this connection is there, after that you have your RFC connection, basically going to your SAP HANA, and then your RFC connection, which is a TCP/IP connection, going to your like ECC, S4, or any of the non-SAP system. Now, in case of non-SAP system, it has to be a database, on the source system. Uh, it could be Oracle, it could be SQL. So for that, basically, we install the drivers, on the SLT server itself, and that installation, is kind of automated, basically. Now, in there is an or ini file, for example, in the Oracle, you maintain the connection details, And once that is maintained basically on the OS level, that is done by the OS admins basically most of the time. And once that is done, you will create the connection in LTRC through to your Oracle source, and that will be a database of this of your source in and as represented in this diagram as well in the source. Now, once that is done, then you will maintain the target connection as well. Let's say it is your sidecar in this scenario, and it's for HANA, you don't have to do anything. Now the library files for HANA is part of the kernel within the SAP. So your basis admin or your basically OS admin will take care of that library files at the time of SAP SLT installation. And after that you give the host name, instance name, and the username password. It will be connected from that perspective to HANA system, right? Now, once that is done, the next step is basically loading the table itself. Now, if we go to this particular one, you will go to LTRC itself, and then you give the table XYZ, that you want to replicate over. You give the table name as XYZ, and it will start with the initial load. The first step is always an initial load. Now, what the initial load means, now we will come to this diagram again. So basically, create table, load the data, replicate the data. Now, once you create the table over here, it will get into initial load. Initial load will load all the entries. Let's suppose there are 2,000 entries in XYZ table in the Oracle database, and it will load all that 2,000 entries from the table perspective to your target site, which is your HANA sidecar, through SLT. And you can see that table is in initial load and how many entries are getting. If you double click on it, it will give you more information in the advanced settings, basically how many entries has been replicated over and how much is pending, and if there is any error message as well, that will show you as well. Now, one thing to keep in mind, basically SLT is not that great with error handling. So it could be a misleading error sometimes, and for that we have some tips and tricks. Once we have system, I will show you the live scenario as well, on that one. But now, once let's say your initial load is completed, all those 2,000 entries are completed, from a replication perspective, and the next step it will go into replicate data. What that means, the replicate data, this third step over here, what that means is as soon as 2001, let's say the new entry get added to your Oracle database, through a transaction, it will pick up that entry basically on a real-time basis, and within the fraction of seconds it will replicate that entry over to your HANA sidecar. Any questions till this point?
No.
Okay. Now, one thing to keep in mind, how this mechanism work. This is the very high level 10,000 feet view of what I just explained. Now, this all that magic is happening basically mostly on your source side of it. And in source side, if you see, there is an application table, which is your XYZ table, what we have used in this particular example. Then there are DB triggers. Each time we replicate a particular table from a source, it will create a two entries on the source side. The first one is DB trigger, the second one is the logging table. Now, how it works is the DB trigger is basically watching. It's kind of a watchdog, so it is a trigger created on table. You can see that as well, all the DBAs, and I will show you as well, how it looks like on the SAP HANA side. So that will give you an idea. It is almost same as in Oracle and SQL as well, but definitely I will show you in HANA how it looks like. So the DB trigger is kind of a watchdog. As soon as the new entry is added to XYZ table, its functioning is it will pick up that entry, it will trigger the replication, and send it over to HANA. So now the logging table, how it works is before it sends to replication table, let's say, there is a network interruption, and in network interruption between your source to SLT server. In this case, let's say this is gone, this connection is gone basically right here. And the logging table is basically logging all those entries which are coming as new to XYZ table, which is your application table. You are not losing that data. Basically, it is logging everything in the logging table. Now your network connection is restored. As soon as it is restored, what it's gonna do is it will watch for entries sitting in the logging table which has not been replicated over. It will pick up all those entries, replicate that through SLT to your sidecar scenario. Are you still with me, or should I explain one more time? I know this is a little bit complicated, but let me use the paint.
So actually, the place where you said like a trigger triggers are activated as soon as the replication is. I mean, as soon as we click on the replicate option, right?
Right.
Not the initial load. Initial load is only like for loading the static contents, like a one-time load. And
Correct.
Only when we click on the replicate, actually, it starts activating two things on the source side. One is the trigger, and the other one is logging.
Right. Correct. That's exactly the scenario is. Now the only thing over here is basically this gets complicated when it is the time of maintenance. So let's assume this is your source. So, and excuse me for my writing, we don't have whiteboard. So this is your source, this is your SLT, this is your HANA sidecar HS. Now XYZ table, let's say there is a table called XYZ over here, right? Now you want to replicate this table over to your sidecar. The first step, as soon as I create the connection, as a first step, basically, I will put my Oracle database username password. I will put my username password for HANA sidecar. My source and connection details are maintained, LTRC transaction code. Now once that is done, I will go to this LTRC, and put there basically XYZ table I want to replicate over. As soon as I say in SLT I want to replicate over my XYZ table, so it will do two things over there. On the source side, it will create a trigger, and the second thing it will do is the logging table, LT. Now the trigger is basically, any new entries coming into this table, basically, it is watching that, it will replicate that over. But before it replicate over, it will record those entries into the logging table as well. It is logging everything. Now let's say this connection goes away, for example, at the time of maintenance, network interruption, anything, so you are not losing your data. If the app, let's say there is an application sitting on top of this your Oracle database, the transaction gets committed, table entry get added to XYZ table, trigger is active, if the trigger is active on this table, it will throw the entry into logging table. Basically, login table will keep recording that till the time this connection is restored back, this network interruption. Now as soon as this network interruption is restored, so all these entries will start flowing through SLT to your sidecar, basically.
So the logging table will only be written if there is any network failure. Otherwise, like it won't be written.
No, it will be written all the time. I'm just using an example for the network interruption, just to explain the scenario. But anytime your trigger is active on any table, the logging table is recording the entry, basically.
So the data that is getting replicated is actually is getting replicated from logging table or the trigger directly.
No, so let's now trigger. I will get into that. This question leads to one step further. Which I was thinking. Just to not to complicate the thing, but I will explain that now. basically. So trigger is of three different types, basically: your delete, your read, and write. And actually, you can see those triggers created on a particular table with the three triggers created on that, with R, W, and which is read, write, and delete, RWD, basically. Now, as soon as the entry is deleted, your deletion trigger will come into play, and it will record that into your logging table as well. Your logging table is recording what's happening with your application table, but it's not holding the data that is sitting in application table. It is recording the stuff what your trigger is asking for, but it is not holding the data. Getting my point?
It's a pointer kind of thing.
It is kind of pointer, but you can say, now tomorrow, if you want to see what, let's say, you want to investigate what happened to my data, why I'm not seeing the data on the sidecar side, or somebody deleted the data basically from sidecar, and you want to go and see whether my data was actually replicated or not, or the deletion entry coming through, or the write entry or the read entry coming through, basically that was recorded or not, so you can see that through a logging table. But
Okay.
logging table is keeping a record of your logs, basically what is happening with your trigger, but it is not holding the data.
Okay.
Right? So in the at the time of network failure, it is holding all the actions, whether it's a delete, whether it's a write, or whether it's a read, it is holding all the actions, but it is not holding the actual data. The actual data is still in the application table, which is XYZ in this case.
Okay.
Okay. And once these triggers will trigger, it will replicate that over, and it will throw that data into, based off your deletion, read, or whatever it is, it will throw that into your HANA sidecar. Now in HANA sidecar as well, there is a
So
replication
here,
cockpit.
one more. I mean, actually, okay. I mean, the place where I'm getting confused is you said trigger and the login. So actually, like where the data is going from to SLT on a
Mhm.
constant basis, whether there is a network failure or whether or not, actually, how is it? I mean, is the trigger pushing the data, or actually, okay, it's just writing a pointer to a logging table, and then the logging table is again fetching the actual data from the database and then sending it.
Come again, I didn't get your question. Yeah.
Now, the data that is being written to, I mean, SLT.
Mhm.
So, which component is actually like writing the data to SLT, replicating the data to SLT out of this? I mean, like a trigger versus logging. So,
So
logging, you said like it only has a pointer, it's not storing the data. So,
correct.
but and the trigger is like basically it is responding to the action of whatever that is happening on the database side, and it is writing an entry saying what type of action is being performed in the logging table. So,
Correct.
is that correct statement?
Yeah, that's correct statement. So, let's divide this process into step by step. For example, you have an application. Your application committed a transaction, which is a new entry in your XYZ table. This is your first step, basically, right here.
Mhm.
Right? Your entry is committed to your Oracle database. Entry added to XYZ table. Now, all right. So now there is a trigger which is created by SLT, which is for your write data. Let's
Mhm.
say the new entry, and the write trigger, there are three types of trigger, but the write trigger will get active in this case and say there is a new entry added to XYZ table. Now I have to write that to the HANA sidecar. Before it goes to HANA sidecar, the step number 2 is basically over here. Your write trigger is active. Now, as soon as write trigger is active, it is calling for the new entry, should get logged into your logging table, which is your third action is recorded over here, right? Now, the one thing basically, and not to confuse you further, but I will get into that as well once we are clear on this part. Now the action is recorded over here, which is your let's say a particular entry from XYZ table, getting into a logging table, which is recorded over here, which is an action. It is kind of a replica of your entry that has been added to your application table, but it is not an actual entry. It is just working based off what the trigger is asking it to do. Now the one thing, and this statement might confuse you or might clear things up in your head. Let's say there is a network failure, or you don't have SLT connection going for half an hour, and you have multiple entries recorded, let's say 10 entries recorded in your XYZ table. Now your trigger is saying basically there are 10 entries, go and replicate that over. Or what it will say is basically in logging table it will record all those 10 entries over here for the time being, because the connection to SLT is interrupted. What that means is those 10 entries is still sitting over here because your network is interrupted, and as soon as the network comes back, SLT will say, okay, there are 10 entries in logging table, pick them up, and replicate that over to HANA Sidecar. What that means is, what that means is, in those scenarios, I will introduce you to a practical situation. We very often we get that during the maintenance or any issues with the replication, your logging table will grow. The reason it will grow because it is holding all those the entries basically, or the actions what your trigger is asking to do. It is holding that till the time your network is interrupted or the connection is interrupted.
Okay.
As soon as this connection will come back, it will start triggering and put that into HANA Sidecar scenario. Is that confuses you, or this make things more clear?
No, actually, okay, the thing, I mean, when the network is down, the information is being written from like a logging table to SLT. That part is sure. But like when there is no network issue, so are we directly writing? Is the trigger directly writing that information to SLT, or is it still going through logging table and then the logging table to SLT?
Still it is going through logging table, but since the network connection or the connection is not interrupted, basically it is not holding that for more than a couple of milliseconds, right?
Yeah.
So that's, I mean, that's the normal functioning. Basically at any given point in time, you are not losing the data basically that is supposed to be replicated over. And logging table plays a really good role in holding those entries. And it is a practical challenge. More often what you get is, in the practical scenarios, your logging table grows. And let's say since you are aware of like BSEG MSEG tables, right?
Yeah.
So let's assume BSEG, it's one of the BSEG MSEG table, which is a high transaction volume table, which is writing the entries basically 1,000 entries per minute, and now your connection interrupted over here, for half an hour. Suppose, per minute it is recording 1,000 entries, in 30 minutes it's gonna collect, more than 5 million entries basically right here. So from that perspective, if you see this table will grow, this is the practical challenge. Now you need to make sure your source database is sized enough to handle high transaction volume tables as well. And that's a practical scenario. More often we get that basically on a regular basis, where the transaction volume is pretty much high in those cases.
Okay.
Right, so that's one thing. Now
So
another,
I mean, in other words, like you need to have high memory. I mean, like to hold enough. Enough space for storing this, like a 5 million record. But actual logging table is still not storing the actual data. It's just a pointer, right? So Is
Correct.
even in that
It is.
case,
Yeah, go ahead.
even in that case, I mean, the volume is going to be a problem, or actually, like the volume issue comes only when it comes to replicating the data to SLT,
Now
not the.
volume issue comes into play anytime your connection is interrupted, basically. Otherwise, the 1,000 entries getting committed to your XYZ table on the Oracle side, trigger is active. Trigger will say, I have 1,000 entries, so login table will say, okay, give it to me. As soon as it is there, within fraction of minutes, 1,000 entries replicated over to HANA Sidecar, and login table is empty after that, right? If it is, everything is working as normal. But let's say there is a maintenance window which is like for 4 hours, and you have Oracle, your source basically still recording 1,000 entries per minute. It will keep recording that into your logging table. It is not going anywhere. As soon as the connection comes back up, it will say, okay, now the connection is back up, I will replicate everything over. But it will take its time, 4 hours basically, for those 1,000 entries per minute, that will be replicated within the next half an hour. But to hold that for 4 hours, you need that memory, you need that basically sizing for the database within your source system. So just to hold that for that period of long. And every scenario is different, every landscape is different, so every need is different. Basically, in the where you are working right now, you need to go and ask them basically at the time of maintenance, what is the transaction rate looks like on the source system, and whether it will be able to hold those entries at the time of a maintenance in the login table or not. If they say no, basically, and that we have to do some calculation on that for the sizing, that's something basis guy and the DBAs will work together on that. And the sizing needs to be properly done. After that, basically, it's all set basically from that point onwards, right?
Okay.
Yeah, yeah. And on SLT side, there is today, I think we will not get into LTRS, but there are some advanced settings as well, in LTRS basically, which is you use for your transformation. So I will give you some introduction about it, but definitely we will cover that with the practical scenario because it's beneficial. And I have to repeat this thing as well, what I have explained you today, but we will go through review with the practical scenario, with that tomorrow, just to make sure we are covering the practical as well. Now, one thing to note is, SLT runs on a component called DMIS, right? So we covered this part thoroughly today, so what is happening on the source side, and these three application table, triggers and logging table. Now when we come to this side of it, which is your SLT is runs on DMIS, which is similar to TDMS as well, your test data migration cockpit. So there are multiple products runs on the same component, by SAP. Now, one thing to note is, DMIS is not new. It has been mature, and it is also useful for the migration of the data from your ECC to S4 kind of scenario, or from Oracle to HANA kind of a scenario in the running production environment as well. At that time also, instead of a data migration optimizer, which is your DMO tool, we can use SLT in some cases, and I have used that as well, back in 2015. But nowadays, DMO is such a mature tool, everybody is using that rather than using SLT, for the replication. Now, LTRC, LTRS, these are bread and butter for you. LTRC basically we covered, that is used for your replication scenario, but there is an advanced options as well, which is kind of, to be honest, impossible to explain this way. But I will try to do that without a system. But and excuse me for that, and I'm really not happy with system not being in hand, to be honest. And after this, or we end up this session, I'm gonna give really hard time to the team as well, to be honest with you. So there are advanced option, for the replication. We will cover that, and then we will go to LTRS as well. Um, so these are the specific in the LTRS scenario, where you have a performance options. You can optimize the performance for the initial load replication process for the individual tables. Now, how you can do that? One of the example is, let's say you have a scenario where you want to report on a specific table, which is a huge table, like BSEC, for example, and you want to replicate that table basically with the initial load, within 4 hours. And it is 1 terabyte of a, you know, um, basically a table. Now, one thing to keep remember, basically, anytime we do anything with SLT, the CPU and memory, both are very less consumed, when we use in a practical scenario. The SLT is network hungry tool. If your network is bad, basically it will kill the performance, rather than, you keep thinking, it's memory and CPU. Memory and CPU is very, very, very optimally and very, very less used when we are using the initial load and the replication scenarios. It is always recommended to have a 10 gig of a network connection between your source and your target, and SLT in between. Now, you can do first performance optimization basically with your network layer, which is with the help of your network team. And there is a guide as well that I will hand over to you, basically how to do a network sizing for your SLT. It's a beautiful guide basically. And um, the second optimization, what you can do is how many work processes you want to assign to a particular table. Let's say you want to assign, are you familiar with the work processes, how it works on the application server?
Yeah.
Okay. So you want to assign 15 work processes, to your particular table, and rest of the table which are in replication, along with the heavy table, which is basic. You want to assign maybe two or three, to rest of them. Basically, you can do that on the fly in the advanced option, and that is very much possible. So that's another thing basically you can do it over here, and that's a part of your advanced settings. Now,
So
second one.
is this different from, is this anyway connected with the number of jobs that we set in LTRC, or?
Yes, yes. So what happens is, basically anytime you're gonna set up your let's say work processes basically to a particular table, and you are giving 15 work process to BSEC, because you want to replicate that table within the 4 hours, the initial load. So definitely you will assign 15. In background, you will see it will create 15 jobs, for replicating that initial load. And that way you will be able to calculate basically how much time it will take, and it shows you tentative time as well, how much time it will take to replicate the entire table, right? So that's a one way to do it. And you are right, basically in the background, it will create a background jobs basically for those work processes.
Okay.
And this is basically mostly, on the performance side, but there are a couple of tweaks as well, that you can do within LTRC. And that is something, system specific again, and I will show you tomorrow basically on how to do that as well in those performance settings. And we will go through, each tab in LTRC and LTRS, so not to worry about that. Basically there is a lot to cover basically when we go through screen by screen as well. But this is still a good overview, to give you basically, and that will speed up the process once we cover the practical tomorrow. Now, in the rule assignment, so you can specify the mapping rules that are excluded during the replication process. Now, what these mapping rules are basically, do you have idea about the mapping rules, I mean, for the replication scenarios? Did you get a chance to work on that yet, or no?
No.
No? Okay. So rule assignments basically, for the mapping, let's say you have um, a particular row in your source table, which has a value as hash values, and you want to convert those values basically into your zero, or maybe you want to leave them a blank basically. So what those mapping rules looks like, so those are based off the particular rules defined by SAP, and there is a particular guide as well, that we will go through basically tomorrow, when we go through the mapping rules. And this is one of the example what I'm telling you, from hash to zero, or you want to change basically comma to dot, in the decimal values, in the binary, in the hexadecimal, all those rules are there already defined by SAP, and those are predefined basically, so, and we can use one of them, in the practical scenario tomorrow. But there is a lot basically, once you get the access, try doing that. That's part of your ETL process. Mostly if you are not doing any transformation, you don't have to use them. But at the time of transformation, so that is very much handy basically at that time. And those are the rules basically we define, if this kind of data is coming in, map to this value, that kind of stuff.
Okay.
Then table settings, basically you can change the structure of the table, target table basically. If you want to trim the table, let's say an example, you don't want to have a particular column, in on a target side. When replicating, you can trim the table basically. You can say, I need column 1 2 3 and 4 5 I need to be trimmed, so I don't need that basically. The structure, you can change that basically on the fly. And that is something you can do that in LTRS. For in the golden rule of thumb is, anything for the replication you will use LTRC. Anything related to your transformation, where you are playing around with the data or the table structure mapping rules, that is LTRS basically. That gives you that option. So in LTRS basically, you can change the structure when doing that on the fly. Now, trigger options for the source system. You can customize the code for your database trigger that records changes to your source system. And this is very rare scenario, and you will hardly run into this scenario unless and until you will get some finicky database admin, who is passionate about the Oracle or the SQL side of it. And in HANA, I can bet you we will never use this, so it's so much optimized by SAP for SAP tools, so it never comes into play. But for Oracle and SQL, there could be a possibility that DBA, who's managing the Oracle and SQL on the non-SAP side, they will come back and say, your trigger is consuming a lot of memory on my Oracle database, and I want you to fine tune this query, so how you were querying my application table and creating those triggers basically. At that time, it might come handy, but I have not seen this scenario, till date basically, from my past experience. Now, any questions on this one?
The table settings, actually, I didn't get that.
Table settings, this guy?
Yeah.
Okay. So, from table settings, let's say you want to append the structure, of your table. And in our example over here, what we were using as XYZ table, and you have, maybe 10 rows, 10 columns, let's see, and you don't want, 2 columns out of those 10, to be replicated on HANA Sidecar scenario, right? So you will go into LTRS.
I mean,
and yeah,
we don't want to replicate 2 records out of 10 records.
2 columns, not
2
records.
columns. Okay.
Yeah. Let's say you want to append the structure basically, of the entire table, and you want basically these two columns are of no use. Why to replicate that over and consume more memory in the HANA sidecar? Let's assume that's a scenario, right? And because HANA sidecar and HANA memory is not cheap. They are per terabyte licensing, very costly basically. So it comes handy basically, when you have to restrict the data replication to your HANA systems basically. And I have done that basically, in few cases where unnecessary data was coming in, and that's where I have append the structure for the table as well, in some cases. Now, or I have added or I have deleted basically. Now my, let's say, XYZ table looks like 10 column, 10 rows, and I don't want two columns out of those 10 to be replicated. So what I will be doing is append and drop those two columns basically. When I'm doing a replication, it's on the fly, it will drop it and replicate only 10 rows, 8 columns, and two columns will be dropped basically within the SLT. So that's a beauty of your ETL
So basically,
process.
like picking only the fields that we want.
Correct.
Of the table. Okay.
Correct. And this is an example for you only when we are deleting. Now you can add as well, and you say XYZ table, you have everything what you need, but you want exactly the same structure plus another column maybe, and for the reporting purposes, for example, and you can add that as well over here. Add and delete, both are possible.
So add which is not there in the database, create a new column. Suppose, for example, any additional column. If there are only 10 columns in the database table, you could have 11 columns in the actual HANA side, right? That's what you're saying.
Yes,
okay.
That's right. Yep. So that's where the table settings, that comes into play. And this is the example basically where we are appending or enhancing the structure basically for the particular table from on the target side. That's why on source side we never do that, because source side we don't want to touch anything. So that's why if you see, you can change the structure of the target table. So that's why it is mentioned only about the target table over here.
Okay.
Now,
and they say, I read somewhere, like I think we don't want to, suppose if you already have data with 10 columns, and then and on the database side, if they added 2 more columns, if you already have a lot of data, I mean, on the target side, is it better to delete that, or when you replicate, actually, since the new records are going to come with additional columns, as well as the old records are also, I think, going to come with new records, new columns, right? So is that a lot of volume for it to handle?
No, from a volume one thing to note, SLT is just a pass through. So SLT is not storing anything except your logging. Logging means, the application logs basically what's happening within that particular engine. So in this one, in SLT basically over here, it is not holding any data basically or anything except your transformation rules or your the code what you're going to put into play during the transformation, or the tables which are in replication, or the connection details, things like that, basically all the configuration. It is not holding any data. For SLT, it is a piece of cake whether you are talking about a 1 terabyte of data, or you're talking about 10 terabyte of the data. Now for SLT it doesn't matter at all, but from a source side you need to make sure logging table is well equipped. We already discussed about it, and in what scenarios logging table will grow, we already discussed about it. Now from a volume perspective on HANA sidecar scenario, that you need to make sure if the data you are migrating basically or replicating basically from the source to target, that should be able to handle. If you have a plan to migrate basically 1 terabyte, then the system should be around 1.5 or 2.5, I will say, terabyte, from that perspective. But from a sizing perspective, SLT doesn't care. SLT is just like, I'm a pass through, I don't care how much data you are passing through. But SLT only cares about two things from a performance perspective: how many work processes you are giving to it basically to better perform. And the second thing is your network. If your network is bad, no matter what you do, your replication will be slow. And I can guarantee you that, it will give you n number of other issues as well, just because of the network is slow. So is that answer your question, what you were trying to ask?
No, okay, my question was actually, suppose we already have the table replicated on the HANA side from one of the source tables, and then they added additional columns on the source table. And during the replication, based on, I mean, like, what are the different scenarios where, like, how do we handle? Because suppose when I think the landscape will, I mean, SLT will automatically bring the old records also, because we added two new columns. So it's going to bring everything, right? To the HANA side.
Yes, if you are not asking SLT to delete the existing and only add two new columns, then it will bring everything plus those two new columns. It will be bringing along to your HANA Sidecar as well. So 100% data replication plus two new columns will be replicated, but those two new columns will be empty because those are not part of your source. So those two columns will be entirely entry, no record in those two columns.
But now we added, I mean, like, actually, let's say like we had 100,000 records, and that was initially replicated. And when we had 100,000 records, we had 10 columns. Now, like, they added another like 10,000 records. At the same time, they added two new columns. So now we have 12 columns, and
you are
110,000. Yeah.
I got it basically. So let me use this diagram. Let's say, I think I can use the same thing. So basically you were saying there are 10 columns basically in XYZ table, right?
Yeah.
And they already got initially replicated to your HANA Sidecar, right? Now, after that, you are adding two more columns, which will bring this number from 10 to 12, right? And now you want to see those replicated over to HANA Sidecar. Is that your question, right?
Yeah. Now, like, I mean, meanwhile, like, when they added these two new columns, actually the records also increased. So now, like, we added 10,000 records, and all those 10,000 records like have these two new columns. So when the data is getting replicated, actually, like, what happens? Does it bring 110,000 records because of the two new columns, or is it going to bring only 10,000 new records?
Really, really good question. So what happens is, if the structure of the table on the source side is changed, in this scenario, in the question what you're asking, there is a more records getting added to source side, plus the structure is also changing by adding two more fields to the table, right? So
Yeah.
in that case, basically what it's gonna do is it will pick up those two new fields automatically, and there is a setting to do that, and not or when I say automatically, it's part of the configuration. Hopefully I can show you that as well. Remember this question, when tomorrow we're gonna see the screen, I will show you the option. Basically, it's just a check mark option, and I will show you basically what to look for. But the short answer to your question is it will automatically pick up the table structure has been changed, so I need to record basically these two fields plus the 10,000 records in those fields basically, and it will replicate that over to HANA Sidecar without doing anything, and if tomorrow any field got deleted on the source side, it will do the same thing. Remember, you have three triggers basically on the application table. One is for read, write, and delete. All three of them are doing their own function basically. Add, delete will replicate over. If you want to just read, it will replicate over basically. So that's the reason basically you have three triggers on that side. So really good, a great question. But yeah, definitely, it is auto populated. You don't have to do anything basically in that scenario.
So like, I mean, when there is a lot of volume, then is it better to delete the contents on the HANA side and do as an initial load in this scenario? Or like, is it still okay to use the replicate, I mean, using the triggers?
I I will answer this into two parts. Now the first one is basically if it is a lot of load and you can I will say afford a downtime for that particular table not to get replicated into a production scenario, which is very rare. In production scenario, you want that table to be online, for reporting purposes all the time. In production, it's very much not possible, to delete the table and then start all over again with the initial load, right? At that time, you have to use that auto option, which will pick up your changes. Now there are some kind of tables which are like a blob table, in Oracle. Basically, those tables are, you cannot do anything with that. I think there is a SAP note which was part of DMS, I think 13, SP13. They fixed that already in for the blob tables as well in Oracle. So it picks up that thing as well. But it is always beneficial not to do that basically if you can't afford a downtime in your production scenario, not to do initial load. But in the lower environment, you can do pretty much anything. You can drop the table, start with the initial load again. Within a couple of hours, the table will be replicated over with everything intact. But you will see the customers are asking. You are in consulting, so I'm using that basically. You will see the customers asking basically, I don't afford the downtime for this particular table. I cannot do the initial load again and wait for another 4 to 6 hours just for the initial load. So there will be a scenario like that. So at that time you can say, okay, so these two entries will take their own time, but they will be replicated over. When I say it will take own time, not more than half an hour. The maybe the if you're talking about 10 billion entries, maybe an hour, hour and a half, based off your network and the background processes. But definitely, that is something possible on the fly. Not, it is always not recommended to do the initial load again basically all over again. Yeah.
Okay.
But in the lower environment, it is very much possible. Lower environment, nobody cares. Yeah.
Okay.
Now, going from a replication logging, replication logging, you can specify the settings of the replication logging. If the replication logging is active, the system saves the replication data, from that perspective. Now, what this means is basically what we have already discussed. Replication logging, we have briefly discussed, how the logging of the table works. It is pointing towards the same thing. So you can view this data and replicate it again from the SAP Landscape Transformation replication server into the target. So what it is telling you is, in case of any kind of interruption, logging table is your friend, that holds all the data, what we discussed initially, from that perspective.
But
Now,
this is by default, it is always active, right? Is it not?
always active, always. As soon as you put the table in LTRC into a replication mode, on the source side, automatically three things happens, or four things happens automatically over there. It will create a logging table, it will create a three triggers that you can see, and you can drop those triggers, and we will get into the dropping trigger, things like that basically tomorrow. There is a lot of scenarios as well for the maintenance and monitoring piece of it. So we will definitely cover that, tomorrow basically on with the practical examples. But that's part of the game basically. It's all active. Yeah.
So if it is always active, then what is the special setting for in under the perform? I mean, like LTRS.
Special setting, I didn't get
I
you.
mean, like actually, if it is already active by default all the time for SLT to work, the logging table should be active, right? So what is this setting that says replication logging, which is doing something extra than if it is already active? Then what else? What other setting is part of this setting?
I mean, I'm not getting your
No,
question.
my question is actually we said it's going to do two things when we connect SLT. On the source side, it is activating the triggers, it's activating the login, right?
Mm-hmm.
And so if it is activating the logging, is that logging same as this replication logging, or is this replication logging something different?
Oh, got it. So in LTRS, basically there is a this setting is, by login table is, as you mentioned, so it is always active basically. There is no doubt about it basically. So if that is not active, that means something wrong with your application. But with this particular setting, what it means is basically if there is a data that is missing on your target site, it is basically doing kind of not CDC. Are you aware of CDC functionality or no?
No.
So there is a thing called, CDC. What that means is change data capture, right? So change data capture is part of your, not part of your SLT. It is part of your SAP Solman, and you can configure change data capture as part of your SAP Solman, which will be sitting on top of your SLT and your source system. So if you read this line, basically, right here, this means that if any data is missing from the target system, you can view this data and replicate it again from your SLT server to the target system.
Okay.
So this functionality comes into play at the time of CDC. So by default, CDC is not active, not configurable within SLT. It is part of your SLT. Now you can compare what is in my source, what is in my target. That's called the change data capture. And if you see there is something missing basically from a data perspective, from the source to target, that means this can be replicated again from your logging table to your target system. And that's what exactly the highlighted line means basically from a CDC perspective. And CDC, I won't be able to cover CDC much into this one, because it's part of the SAP Solman. But definitely I can give you some overview if you are more interested in listening about how the CDC works. And it's I will not say a rare scenario. It is a very great tool when you have a lot of reporting scenarios, and plus you wanna you comes with a data, but you are coming with a data background, so you will be able to correlate this one. Let's say you have a report which is showing a missing data, and you started investigating, troubleshooting what's happening, so you were able to figure it out, the my Sidecar data and what my report is showing is exactly the same thing. So there is something has to be from the source side, from where the data is coming from. Now you will run the CDC, a tool basically sitting on your Solman, compare the source table with the target table. That will give you a report. Basically, this data is missing from so and so date, so and so column. This is it's a very mature framework, in that. And I can hand over you some documentation around that, standard documentation. But I don't have Solman system to show you, to go through that basically. But at that time, you will what you will do is you will get into LTRS, and check mark this option, say activate the CDC option, and this option you cannot activate if your CDC is not configured in system. And what it will do is, instead of replicating the data all over for the entire table, it will replicate only the missing records at that time.
Okay. So like generally, like, do they activate a CDC all the time in general, all the customers, or
It's
like
it's a very, I will not say rare scenario. It is more of, as per your need. I have seen environments, and specifically BW consultants, who are working day and night on the system with a complex data models, data lakes. They use CDC functionality a lot, and due to the nature of the data or the reporting structure are so heavy, so they use that. And I will tell you, if I have seen near about like 24 environments, and out of that SLT was implemented basically in 4 or 5 environments, I have seen 50-50 ratio at this point in time. So I have seen that, I have not seen that, it's kind of a 50-50 ratio basically. But a lot of people also doesn't know what CDC functionality is, and that is based off lack of skill set on the basis side. They cannot configure it, or maybe the lack of skill set on the BW side. They don't know, what to use and what scenarios to use basically.
okay.
But it is useful, if you ask me personally, I will tell you, it is very useful tool if you are really deep into the data, where the data network is basically, too complex, and a lot of non-SAP data sources are there, and then you have SAP, and you have the, joint queries, then you are doing a reporting on top of it. Definitely it's a very useful tool, at that time basically.
Okay.
Now, coming to job management, we already discussed about it, but the data loads and the SAP replications jobs, all of them has a naming convention, LTB, job dispatcher. Basically, these are the dispatcher job, which is dispatcher jobs comes with the MTI, your MT number. Basically, remember when we create a connection, it comes with a connection number, which is auto populated by the number range, and that's stored in the backend table. So as soon as the connection is there, every connection will have one dispatcher job. It is a standard job basically, so that's very much, with each connection you will have one dispatcher running in background. And then you will have a master controller job. A master controller job is creating a triggers, login tables in the source system, so all that work is done by your master controller job basically. And as soon as you put the table into replication, first table into replication, you will see this job 1LT 1UC, and with the MTI ID, MTID that will be running, let's say 007, so that will be, CNRT 007 will be running. That's how you identify this this particular 007 belongs to a particular connection that is coming from a source Oracle or SQL, or anywhere from ECC or somewhere else. Then third type of job is, your data load jobs. These are very much important. If these are not running, that means your data replication is not happening, and even the initial load will not go through if the data load job is not running. Basically, it is loading the data, replicating, changing the status of the flag entries, all that is part of this job, and that it is also represented by MTID, in this one, in this case. Now, when we were talking about how to make sure we are like BSEC table is replicated within the 4 hours, so when we increase the number of work processes for that particular table, what we are doing is these jobs are getting triggered 15 times. Data jobs, you will have only one master job, master controller job. You will have only one dispatcher. You will have multiple data load jobs basically, based off your how many processes that particular connection or the table is using.
Okay.
Then migration object definition job. which is your, each object basically. In if we take any table, in SAP, that is represented as an object, in database, in application layer, in the programming as well. So that is an object. So you will have a naming convention starting with this, with the MTI ID, which is a migration object definition job. What it is doing is what my definition looks like for the job, for that particular object, so that is what is recorded within that. Now, the access plan calculation job, this is very important basically, from access plan. Are you familiar with SQL access plan sitting on the database?
Yeah, when I mean sometimes performance issues happen, like with the help of DBAs.
I mean, from a development perspective as well, right? When we are writing down a code, it hits the SQL plan, for example, so it hits the database. It will show the what is my access plan looks like for that particular SQL, so this is what we go after, what my access plan looks like when there is a performance kind of issues with that particular table, other than your jobs and network. This is at the coding level, and this is something you can change, but very, very rare scenario. Most of the time you will end up opening a incident for SAP stating that this is my standard access plan looks like, and this is giving me a performance issues in my system, so they will give you some kind of a node correction for DMIS component, which will fix your issue. But in few cases, where you have to manually change access plan, basically that's not recommended at all. But in some cases we might do that, and that is done on the source side, running the SQL basically, or the access plan manually. And once we trigger that manually, SLT will figure it out, the XYZ access plan is in run, and it will run this access plan calculation job within SLT server as well. But very rare, very, very rare scenario. So again, I will say nothing to worry about it basically from that perspective. Notification job, all your monitoring health checks basically, your how your MTID is doing, so now when we talk about, definitely we will talk more in deep tomorrow about the monitoring piece of it. I just want to cover this basically till health check, and and really a quick time check, and I will get back to you on that one. But this notification job is running at the MTID level, so let's say tomorrow you comes into a morning and you see how is my MTID 007 is doing, and overall. So there is a notification setting. You will put that in your, any distribution list or your own email. Every morning 9 a.m. it will trigger the this job will run, and it will send you a status in your email. That's how your 007 ID is doing right now, or XYZ table is sitting in error mode. You have 15 table in replication, 14 are in replication, all okay, all green. One of the table is in red status. Go and check now. So that kind of stuff. That's where the notification sanity job that comes into play. Now
so we will. I mean, based on the frequency of the job, like, or is it going to just consolidate everything? I mean, and send only like a time. I mean, based on the frequency of the notification job that we're going to set, like it's going to notify us every few hours or daily once.
You can set the frequency every 60 seconds. And even I think 30 seconds as well. I need to check with the latest SP level where it is, but I think 60 seconds is but nobody do that basically every 4 hours or 5 hours. I've seen administrators doing that. And if something is
even though the table replication frequencies are different, this job is going to periodically execute and provide status on all the tables during that frequency.
Correct. So it is kind of a health check. So if you see, it is talking about the specify the settings for your health check and the notifications. Basically, it is kind of a health check for your SLT MTID, that is giving you, oh, this empty ID is doing, all right now, for that basically. So that's what it
Okay.
is for.
Okay.
Now, housekeeping job, it deletes the unwanted, basically any lingering around tables, object, access plan, any logging, basically unnecessary. This is the kind of a housekeeping job. This job is running on a regular basis in a system. If this is not running, that means you are growing your SLT database unnecessary, because you want to keep the logs up to 14 days, 30 days, 60 days, not more than that. And you can define the retention period within this housekeeping. After so and so date, just delete all the logs, all the access plans, everything related to the particular table, particular empty ID. That's what the housekeeping is for basically. Now, health check, basically, there is a health check job, which is periodically running, which is controlled by LTRO. And LTRO is advanced monitoring as well. Once we get into the monitoring, in this section, I will be able to explain a little bit more. But on the health check, basically, it is more of checking the health check for your SLT. Basically, anything running in your LTRC transaction, it will give you the snapshot of that, and you can convert this health checks into your notification as well. And we have already discussed that basically, and that's why it was referring to health checks in this section as well.
Okay.
Now, quick time check. We we started 15 minutes late. So we are almost 2 hours, but I want to cover this basically, changing the numbers of the job. Since we already touched this one, so another 5 minutes basically, I would like to touch on this one basically, in the stopping and restarting jobs. That will, I think that will be quick. So stopping and restarting jobs, basically from LTRC, you don't have to go to SM37, 36 to do anything with these jobs. Basically, anything and everything can be controlled within the single cockpit, which is your LTRC. Is your friend basically, and you can stop and start the entire empty ID. Within the LTRC, and that will stop all the jobs what we have discussed in the previous screen. So if you are suspending the particular connection ID, which is your empty ID, then it will stop everything from that perspective. Or if you want to restart all the jobs, that is also possible. And there are scenarios where the connection is in kind of jeopardized mode, where connection is still active, but it is not doing anything. That's where we go and say, let's restart all the jobs, and that might fix the issue. It is one of the troubleshooting steps as well, when we are doing a troubleshooting. And DMIS component, pretty frequently it behaves this way, and this is one of the step to remember, when you're working in a practical scenario. Changing the number of jobs, we discussed with the example, like in BSEC, if you want to do the 4 hour thing, it's talking about the same thing over here in LTRC. There is the on the fly, let's say your BSEC is already in initial load, and after half an hour you are seeing, and I'm taking that example further on, just to give you more about the changing the number of jobs. So after half an hour, you see, this is running really slow, and I want to make it more fast. I want to complete this within 2 hours. So I want to assign more number of jobs to this particular table. On the fly, you can change that, and you can, as soon as you click on save, after changing the number from, let's say, 10 to 15, you will see 5 background data load jobs getting populated at the real-time basis, without stopping the initial load. So that is something very much possible, on the fly. You don't have to do stop and then start all over again. And it is again talking about the speed of the initial load, then more resources initially available. Basically, you can increase the number of data transfer in the initial load jobs, all that. But the crux of that is, the example what I just explained to you, that's what it is used for basically.
So is this still in LTRC?
Yeah, this is still in LTRC. There is an administration tab basically in LTRC. That's where you see basically there is and that's one of the tip and tricks. It's I will say nowhere documented. Now it should be. I'm talking about almost 2 years back. So nowhere documented initially. It is one of the trick is basically how to change the number of jobs on the fly, and that was part of the initial tips and trick. But I will show you tomorrow, where to change that basically practically in the system.
And we had the LTRS also. We had this option to increase we had option to increase the number of processes, right? What's the difference between
in the advanced setting? It's both are same thing, so in
both
the
are same
advanced,
thing? Okay.
yeah, in the advanced settings as well, there is an option, and in LTRC as well there is an option, but both are same thing basically, so there is no difference in that. If you increase those numbers, the in background what it is doing is it's creating more jobs in the background basically.
Okay. And suppose like if we have 3 or 4 systems, I mean like we have ECC, we have transportation management, EWM. So we have to establish this MTID, I mean connections from each of these individual systems, right? Separate connections. And
Yes.
when we do that, how do we, is there any way, like, do we need to provide any dependencies? So, okay, suppose if dependencies between the tables, or if something stops in between, and that data requires has dependency on the other table coming from different system, how do we take care of that scenario?
Sure. So let's say you have let's assume you have 3 source system. One is your ECC, another one is S4, another is your supply chain system, SCM, and you want to replicate that over basically to your sidecar. So you will create 3 connections which will have 3 empty ID, 007, 008, 009, right? Now these 3 IDs are not interdependent with each other. They don't have to they don't have anything to do between these 3 empty IDs. They are not dependent with each other. Their tables are not dependent with each other's. Their work processes are not dependent with each other. You are giving as a total resources of the work processes to each one of them. Let's say you have 45 work processes, you have assigned 15, 15, 15, so that's how you have divided, but they are not dependent on each other at any given point in time, from any object perspective, any table level perspective. No access plan, no triggers. Each will have their own triggers, logging tables, access plans, the jobs, everything basically. They are individual identity within the LTRC over there. So now if you want to replicate a table in ECC, and let's say ABC table, and the data ABC has a dependency on SCM XYZ table, because you want to merge that table for the reporting purposes, or you want to have the data in a consolidated fashion in the sidecar, but that's your need. SAP SLT doesn't understand, the any dependency that way. So you will be replicating ECC. Let's say 007 is the MTI ID for your ECC. You will replicate ABC table in MTID ABC over there. Then you will go to MTID 008. Then you will replicate XYZ table over there. There is no dependency, and SLT doesn't know any dependency between these ones, or within the MTID as well. In ECC as well, you have ABC table and XYZ table. They are also no dependency. Basically, you have to do that each table replication manually. You keep them adding that, or you can upload that via Excel sheet. At once. 1,000 tables at once. They're all done. Copy paste. So, uh, from a dependency perspective, the answer to your question is, you have to define that dependency. SLT doesn't understand any dependency between any of these.
So since these are independent, let's say like if we take, I mean, material master or like any business partner, which is coming from ECC, and some transactions are happening in other systems using these objects, products, or like business partner. So when we come to HANA, like, I mean, yeah, these are getting replicated individually, and there is no relationship as far as SLT is concerned, because the MTIDs are different and the connections are different. And
Right.
now, like, we have the tables on the HANA side. So when we design the HANA views modeling, like, how do we, I mean, like, do we need to take care of any of this into consideration? Like, because suppose if one of the connection stops and the data is not replicated, or the materials are not getting replicated from ECC, but the transactions are getting from other system. So when we run the query, like, are we going to have any inconsistencies, or do we need to consider anything during modeling for this scenario?
So you have to consider this within the modeling piece of it. When you are doing modeling for the data after the replication is done in Sidecar, you have to take care of this in Sidecar, rather than doing that in the replication or in the transformation scenario. There is no way you can define the dependency or the business process dependency between intersystems or within the system as well. So SLT doesn't understand. SLT is just a data replication tool. It doesn't understand any smartness between how. Remember, if you are familiar with Sara or Sari, how we do archiving basically. If you go and put the object in Sara transaction, for example, you click on the archiving graph on the top, it will show you, these XYZ tables are dependent, and you have to archive these tables, along with the parent table. So that kind of a network graph is there within the archiving scenario. But when it comes to data replication, there is nothing in SLT, that will define that kind of a scenario, within SLT. You have to take care of that piece within the modeling once the data is replicated, and that is something, within those analytical views, your attribute views, calculation views, everything, once we cover those topics, we will touch base on those things at that time.
Okay. And also, like, I mean, is there any constraint on any like maximum number of systems that can be connected through SLT?
No. No, there is restriction on the licensing piece, specifically talking about Oracle databases on the source. There is some restriction, and what the restriction number looks like, I need to check. I am off on that, but there is a licensing restrictions from Oracle perspective. But other than that, there is no restriction how many connections you can create. But one thing to keep in mind, your hardware should support and your network should support that many number of connections. If you can make sure these two things are okay, then you can create n number of connections basically.
Okay.
Yeah, but there is some restriction on the Oracle side basically, and I will search for that note. Let me take a note. Oracle restriction. Okay, SLT. I will provide you that note. With the restrictions.
Okay.
Yeah, and you know, this covers basically pretty much your LTR, C and S, C very much in depth, but still the practical thing is not there. So excuse me for that, and I apologize. And let me get along with Alok after this and see basically what's going on. And tomorrow we will cover the LTRC in depth one more time with the practical screens, and LTRS as well, with couple of options over there. And but meanwhile, if you can read about the mapping rules, so read about the mapping rules little bit, and then after that we will discuss in LTRS basically more on that tomorrow.
Okay, yeah, sure. And when I'm also going to send an email to them for my access. But could you please, when you talk to them, could you please inform them to provide the same access that you have, and
Yes.
and I should be able to create the connections and then do everything, but that kind of connection access like same as you.
Yep, definitely. And yeah, good night. Thank you.
Yeah, see you. Bye.
Bye.
Thank you for attending the session. I hope you all enjoyed it. Don't forget to like and subscribe to our channel. Also, feel free to ask your questions in the comment section below, and we will reply to them at the earliest.